Hi guys, what I want to try to describe to you is how I put together my lower tread section and try to describe some of the little parts that how I put it together. What I have here is I have the donut, and on the donut I have the rocker bearing that sits inside the donut. As you see here, I did not cut out the center of my donut, so the rocker bearing sits inside, which it's only up approximately, after sitting flat on there, about 1/4 of an inch. On top of that, I have bolts that are mounted from the underside of the rocker bearing in 4 locations. With that in place, I then set Andy's PVC gear set on top of those 4 screws. I right now have bolts on them that hold this steady in place, but when I'm actually putting it together, the bolts will come off, the nuts will come off, the torso will sit down on top of through these 4 holes and sit directly on top of the bearing, except it'll be sitting on these washers on where the screws are. So that's how far above it is. I will tighten it down from inside the torso, and that will keep it nice and steady. What you also see here is part of Andy's PVC gear set is you have 1 large gear and 1 smaller gear. There is a gentleman in our R2 Builders group that makes a hub that's specifically designed to mount the small gear to this aluminum hub that sits into a 1/4 inch shaft on the motor I have, and you'll see it on the underside when I lift up the donut. I also have Molex connectors here that pass the signals to and from the batteries, which is our main power system down below, and the control signals that are up in the command central to and from through these Molex connectors. So when I set my torso down, all I do is plug in 2 plugs, and that takes care of all my electrical connections from the power system to the command central. Now if we lift the donut, you can see under the donut where I have a couple blocks of wood that give the donut some support, since I'll have the torso resting on it. You also see I have a high torque motor that is mounted directly underneath the donut. For the ones that have not drilled out or have a hole inside their donut, I mounted it right to the donut, which made a real nice connection from there to the small gear on the top. All the wires you see here are from the power source down below, and the control signals from the command central. Here's my Vantec motor controller that drives the feet motors with all the connections. Looking underneath, you'll see where I have the 5 batteries. This is all the power system that the robot uses. I have 1 battery, 12-volt battery, just for the Neon. I have 2 12 volts tied in series to give me 24 volts for the main power system, and then 2 batteries tied in series for 24 volts for my tread section motors. As you see here, I have them sitting inside, and how I did that was using Mark Thompson's plans. On one of the leg sections here, instead of cutting the inside out, I decided to leave the entire piece solid except for 2 2-inch holes I bored on either side of the wood piece that allowed me to pass the wires from the tread section up through the leg section to the connections to the batteries and back down again. Other than that, it provided a nice flat stable surface that I was able to set all the batteries on top and connect it up. I surround it with nice sponge foam that keeps it nice and quiet, and everything stays nice and steady in there. What you see here, this is Andy's new PVC waist plate. It works and fits very nicely on top of the leg section. Very nice. I'm very pleased with it, the way it sets. Part of the system is to set the donut into place, and by doing so I have the holes on the underside that will allow it to sit inside on the bolts and allow it to lock into place. So that just locks it nicely into place, and that basically, with the tread section, I have the scooter motors that are located down in each tread section. With what I ended up using for the wheels right now are my son's rollerblade wheels that I have 2 wheels, 1 on either side of each tread section, with 1 5-inch wheel that's located on each tread section. That is the main driving force for this robot. It has great, the Vantec motor has a lot of current capabilities, and it works out very well. So basically, that, using the foam system of Mark Thompson's for the legs, I took this up to 17 inches. That's how high this is. Mark, in his plans, usually does 14 inches. I decided to let it sit the full 17 inches. I'm very pleased with the height of it and how it turned out. So again, it worked out very well. So that basically concludes how the lower section goes together. Thank you.